So yes, here's our second meeting. Definitely going to be a bit more exciting than last week. I know we just sort of reiterated everything that you all have already heard in the emails. But for tonight's topics, we've got the old business, tell you about a couple things that happened over the past couple weeks in unmanned systems. We're going to talk about what are unmanned systems, their accessibility and availability for us civilians, and finally we're going to go over some characteristics and traits of those unmanned systems. So first off, old business. The fun fly that I talked about last time was really cool. We had about 20-25 people show up. We had helicopters out there, we had miniature ones, scale helicopters, same thing on the airplane front. There were a surprising number of multi-rotors out there actually. Vast majority of MMRCA are some older dudes, so I was pretty surprised to see as many of them accepting of FPV platforms and multi-rotors as there were. So yeah, those will be going on. Obviously winter's coming up now, so not going to be too much going on in the flying realm, but yeah, starting up in the spring. If you guys are at all interested in doing that, holler at me, we'll get you out there. They do meet at Shakespeare's South every third Wednesday. I know that that sort of kind of doesn't mesh well with our meetings, but if you guys are interested in going out there, again, really cool group of people, good group of people to learn stuff from. We have the design contest. Pine, you might not be aware of this, but basically, so on our OrgSync page, we've got that nasty little gray symbol now that's just generic. We're having a design contest where if you can come up with a symbol, crest, whatever you want to call it for us to use for OrgSync, as decals on any of the unmanned systems that we create, et cetera, et cetera. The winner will be voted on by the entire team, and whoever wins will get a free unmanned system from Amazon, basically an RC, car, plane, or boat, whatever you want, anywhere between 50 and 100 bucks. I'm going to work with the winner at that time, and we'll sort of figure out the best thing that you can get from Amazon at that time with that amount of money. And then finally, if none of you guys are aware, we do have a Facebook page now. I'm not caught up on who is a member on there or not, but if you're not already, go ahead and join that. Post all sorts of fun stuff on there. Hopefully whenever we get more members, you can start arranging, put up research ideas, get other people interested in the research that you want to do, basically be just another hub for us to communicate through. So, yeah. Over the past 2 weeks, we've had some interesting things happen. The Michigan Police Department standardized their UAV platform on the Arion Sky Ranger. They use UAVs for officer public safety training, natural disaster response, search and rescue, traffic accident reconstruction, a few other things. They do this over 83 different counties, and they are hoping to receive their Certificate of Authorization, or COA, to do this all over the state pretty soon. Senate Transportation Committee in New Jersey voted unanimously to pass the self-driving car bill that went up there, which is really cool. Senator Tom Keene Jr. Told the local news station, "We should be creating the jobs, creating the opportunity, creating, in fact, the mobility people want in this day and age." Which is really cool to hear a senator say. Usually we think of our political figures as people with heads up their asses. So it's nice to hear every so often that, they're thinking with their heads straight. Yep.
What was the driverless car bill?
I'm not sure specifically. If you want to go to auvsi.org, I didn't copy down, the entire article or everything, but from what I understand, basically the bill was for it to be implemented, tested and implemented in New Jersey. So should a company be able to create a driverless car that can be proven to run, correctly, that would be legal to pursue in New Jersey. So, of all places, New Jersey. And then the National Science Foundation has given a pretty heavy sum of money to the University of California, Berkeley, to develop the next generation of surgical robots. Some aspects of hip and knee replacement surgery have been done by robots in the past, but autonomous surgery on soft tissue has yet to be realized, and there are a team of researchers at Berkeley that aim to change that. So hopefully we see some more news on that in the next few years. And then finally, UAVs were actually banned in India for civilians. Not, for the unforeseen future, but India as a nation has decided, you know what, until we get some laws in place and we figure out how we can, work out a system for UAVs for civilians, no more. They just cause too many problems there, apparently. So, again, very cool that they're not just outright saying we're done, no more. They are working towards getting a system so that civilians can once again use UAVs. If you want to read more about stuff like this, go to that website. You can sign up for their email newsletter, or you can just read through the page. Very cool site for getting information on the world of unmanned systems. So with that, let's go ahead and get started on our lessons. What is an unmanned system? Basically, anything that can be controlled without having a human being physically on board classifies as an unmanned system. So could be, as we see here, RC car, underwater toy, paper airplane. I know that's an atypical sort of example, but totally qualified. There's actually a humorous video out there of someone, cameraman's filming and he says, "Hey, you should fly that paper airplane." The guy goes, "Okay," he throws it. And then the cameraman says, "I'll give you $1 to do it again." He says, "Okay," and he throws it, and the joke being that that is then a commercial use of unmanned aerial systems, and that is technically illegal. So, I know, right? Also, humorously enough, if you think about it, a microwave is technically an unmanned system. A human being interacts with it in order to achieve the desired results, but doesn't actively participate in the microwaving process. Though that would be cool if we could do that. So, significantly fewer unmanned systems can boast autonomous capabilities. In the world of unmanned vehicles, autonomy is the name of the game right now. Autonomous operation of an unmanned system provides a vast array of advantages over one that needs to constantly have input delivered or monitored by human beings. Basically, the less that we have to do in order to obtain useful data from our system, the better. Autonomous operations allow for people to focus on the other aspects of the problem that they are trying to solve that still do require input, monitoring, etc. They also remove the risk of human error, assuming that the unmanned system is, of course, configured properly before being operated, and does allow for more fine-tuned response time than a human being could ever achieve realistically. Autonomy is achieved in a variety of degrees of success. The most important deciding factor in that level of autonomy is generally the autopilot, or sometimes referred to as a flight controller if you're talking about unmanned aerial systems. The autopilot can kind of be thought of as the brain of the system. If the rest of the system is a body. Just about every component of the system is going to be connected to the autopilot in some way. The autopilot acts as your primary interface between you and the system. The level of autonomy that is achieved depends on other factors, such as software used to program the autopilot, the hardware that's attached to the system. Some payloads, may need to be controlled separately, or their function may not easily lend themselves to autonomy. But the main point is that the autopilot is your big factor in autonomy. Going back to our old microwave example, technically you could even consider a microwave an autonomous unmanned system. Human input is required to program the autonomous activities of the microwave, which is heating up your food. But once the user hits start, it carries out its task until done. You can sit there and watch and make sure it doesn't bubble over, boil over, or anything like that. And then, after it's done carrying out its task, it stops, sits there, sitting patiently in what you could consider like a standby mode until its next mission. So, to avoid anyone confusing our team with one that builds or competes microwaves, pictured here is a very simple diagram of the various components of an unmanned system and how they're linked together. This is from an air-based system, but it shouldn't be terribly hard to draw the parallels between how this would be shown to represent a land or a sea-based system. The autopilot, is the brain, obviously. Everything connects in there. I'm not going to belabor the specifics or anything, since we're going to be touching on the characteristics of unmanned systems a bit later. But this should give you some high-level understanding of how the unmanned systems that we will research, develop, and use are configured. So as a quick recap on that, for unmanned systems, there's no human pilot on board. Some level of autonomous behavior is ideal, generally controlled through an autopilot should that autonomous behavior be there, and for the purposes of our team, it's not a microwave. So now that we have a rough idea of what an unmanned system is, let's talk about accessibility and availability. If you look around online, a lot of different kinds of unmanned systems out there. Some of them cost less than $100, some of them cost more than $50,000. There's a number of reasons why I can't go out and purchase, for instance, an MQ-9 Reaper right now. Money is not the highest of those options, by the way. Basically, the biggest one is that civilians can't own them. There are a lot of unmanned systems out there that are designed for and strictly sold to military personnel, usually equipped with more advanced hardware, and their payloads tend to either be reconnaissance or combat oriented. As a brief aside at this point, you'll notice, or may have noticed rather, that I dance around the word drone a lot. That's because drone, in the eyes of most people, has become synonymous with thing that kills people outside of eyeshot, or thing that spies on me in my personal life. Obviously saying drone is a lot easier, but when you're talking to your friends and family about the sort of side projects you've been doing in classes, you may want to think about how the public, or in your case, your audience, sort of views the D word. So use that with caution. As far as accessibility is concerned, you can find unmanned systems in a variety of configurations for sale, from the websites listed here and many, many more. Actually, in fact, I have never purchased anything from any of these websites. These were the top 4 results when I Google searched RC stuff. So pretty obvious, a lot of places you can go out there to get this. Generally speaking, there are 4 different formats that you will find an unmanned system for sale. You've got kits, which are usually sent to you almost completely disassembled. They usually don't include things like your motor or an autopilot or anything like that. It's just your airframe. Adhesives or epoxy might come with it, might not. Always take a look at what comes with a set whenever you're purchasing one. There are almost ready to fly, or ARFs, ARFs. The system at that point is sent to you either completely or almost completely assembled. Usually all you have to do for that is install your own receiver and have your own transmitter, and then bind the two and you're good to go. There are bind and fly systems, very similar to the ARFs, but with a bind and fly it does include a receiver, so you can just about literally take it out the box. You might have to do 1 or 2 things to put it together, bind your transmitter, and again, you're good to go if you got a battery all charged up. Finally, there are also ready-to-fly systems, RTF. As it sounds like, they are ready to fly. You take it out of the box, you put a battery in there, and boom, comes with the receiver, comes with the transmitter, comes with everything you need. And pictured here, some examples of all of those. Your kit plane up there, your bind and fly. You can see this particular bind and fly kit up here does come with, looks like a battery, a charger, a few other things. Almost ready to fly kits. This one in particular doesn't come assembled. This one does have you do the assembly, may or may not come with other stuff, and then you've got your ready to fly, your Phantom 2. So the accessibility of unmanned systems have good and bad sides, just like anything else does. For your pros, you know, it's pretty easy to get people that are interested started in this sort of thing now. You can go pick up one, like I said, sometimes for less than $100 and sort of whet your curiosity. Plenty of platforms to choose from, and they're relatively inexpensive. I mean, if you think about it, how many other ways are you going to get, you know, something cool to fly around in the air, travel around on the ground, or go into the sea, you know, for sub $1,000. But on the downsides, customer service and product quality are very variable between places. There's one website called Horizon Hobby. They're actually based out of Illinois. I've had excellent experience with them. I actually ordered something from them. I got a bad battery with my order, called them up, and they were like, oh man, that's really terrible. We're gonna go ahead and send you a new one. I told them, well, do I need to send you guys back the old battery? And they're like, no, that's dangerous. Don't send LiPo batteries through the mail yourself. We'll take care of that. You're all good. It's like, wow, all right, cool, thanks. On the flip side of that, there is a very popular website called Hobby King. You may or may not have heard of that. Their main warehouses are based in China. They do have US warehouses now, but a lot of their products are not fantastic. Generally speaking, it is a crapshoot as to whether or not it will work or not. If it does work, it probably probably doesn't work to the specs that they listed on it. That's just one of those places where you sort of have to cross your fingers and hope it works the way they say it does. If you need to return anything, depending on which warehouse you got it from, that can be a hair-pulling experience. It sucks having to ship stuff back to China and wait for that to come back. On the plus side, they do pay the shipping for it, but yeah. Bind and fly and ready to fly systems can lead to people not fully understanding the hardware. I'm actually a little bit guilty of this myself. You know, I'm an IT student, so when it comes to the mechanical engineering side of things, I sort of lag behind. I'm learning as I go, but yeah, if people stick strictly to the BNF and RTFs, then you tend to not know nearly as much about the inner workings of what's going on. Furthermore, since they're so inexpensive, really anybody can buy one, fly it, and crash it into somebody. To that point, I've got a link that apparently I can't copy and paste from the notes while this is going on, but just hit a dude in the face. Such epic words. So yeah, that can happen. And if you look around on the news, or maybe you've seen this in the news yourself, it happens. It probably doesn't happen as regularly as the media would like us to believe, but nonetheless, they do gather these stories pretty often. Some things to understand about that video. Number one, probably pretty obvious. The pilot more than likely did not intend to harm anyone or anything. Rarely when you see these videos are those things being done intentionally. News stories also really don't comment on that usually, you'll see. It's just, whoa, this person crashed a drone into somebody and it's terrible and they're bad. So you could argue that they're right to do that. Operating with the best intentions is not the same as operating safely. So, and you know, pilot did not intend to hurt anyone, doesn't get as many clicks and views. Number two was likely not a pilot error. In my opinion, I watched this video probably 2 or 3 dozen times. The system was stable until about 17 seconds in, where you saw it kind of dip to that one side there. If I had to take a guess, I would say that there was some sort of drop in communication there. It could have been that that there was a lot of signal noise going on near it. Could have been low battery. Oftentimes, if your battery reaches too low, signal will cut out and you won't have control anymore. Could have been a hardware malfunction, could have been one of the motors, it could have been the flight controller, it could have been one of the electronic speed controllers, on and on and on. It doesn't look like pilot error to me, but who knows. Generally, to figure that out, you do need to take a look at the logs of what happened. Your autopilot will always log things that are happening. But again, you'll notice that the media does not really care about this sort of stuff. I guess the biggest thing I want you guys to take from that video, though, is that anything that can go wrong needs to be addressed. For example, I gave a talk on multi-rotors right here about a month ago or so for Hack Mizzou, if you guys heard about that. One of the things that I wanted to do was fly the multi-rotor around this auditorium, but I ended up taking a look at the risks and didn't think it was worth it. The Wi-Fi environment was significantly more noisy that weekend because we were supporting some 300 individuals on campus that don't have call prints and things of that nature. There would be an unknown number of people coming to the talk, so I didn't know how much safe room I had to fly in. Also, the multi-rotor wasn't as stable as I wanted it to be, and that was partially based on the multi-rotor that I was sort of talking about then. In order to orient itself and keep itself horizontal to the ground, it uses an imaging camera on the bottom and it looks for different features sort of to keep itself level. So for instance, over this space here, there's a nice little metal square around here. That's a pretty glaring difference in the ground. So the multi-rotor would have been able to keep itself stable right about here, but then flying anywhere here where the carpet is just dotted and, aside from the nasty stains from students and everything, there's not really any defining characteristics of the ground. So again, just if you're going to be flying, whether it's inside, outside, anything like that, always be conscious of what could happen and plan that it will happen. Sometimes when I go flying out at Hinkson Field, it's a huge area and everything, but if anybody starts jogging around or is walking their dog out there or anything, I land. I mean, statistically speaking, probably not going to crash into them, but I don't even want to take that chance. I don't want to make people feel uncomfortable. Unmanned systems already get a bad enough rap, so I don't want to add to that. On that sobering note, let's talk about availability. Availability differs from accessibility primarily in that while there are a plethora of modules accessible by everybody in the world, not all of those modules are available for use by an unmanned systems operator based on what country they are operating in. For example, there are two common radio frequencies used for telemetry, 900 megahertz and 433 megahertz. Here in the US, we use the 900 megahertz frequency because the 433 megahertz frequency is very restricted in the US. You can take a look at some FCC documents if you want to see how it is restricted and why. Other common frequencies that are used for unmanned systems are the 1.2 gigahertz spectrum, the 2.4 gigahertz spectrum, and the 5.8 gigahertz spectrum. Different countries have different rules for each of these frequencies, usually in order to differentiate between frequencies that civilians can use and ones that are reserved for government and private use. And thus what may be legal and usable in one country may in fact be illegal and or unusable in another. It is very important to take country regulations into consideration, both to ensure safe operability and to ensure that you're not taken to jail by inadvertently causing signal interference to important government infrastructure. For example, let's say that you've got a transmitter and receiver operating on 933 megahertz. In the US, it's perfectly legal. You can expect to operate the system with just the issues that are inherent in radio communications threatening to interrupt control. However, in Europe, the 933 megahertz frequency is used as an extension of GSM networks or 2G cellular data. So that same frequency that you use in the United States will likely either have very spotty communication or no communication whatsoever because there's so much data traveling over that frequency and your transmitter signals are sort of lost in translation basically. On the off chance that a member of government were monitoring your radio signals, you might even be taken to jail or fined. So that totally sucks. Don't do that. Over the summer, the FAA issued a notice to the public that, among other things, it was their opinion that FPV flying should not be allowed without a COA, Certificate of Authority. The COA is a 30 to 60 page document that the FAA requires unmanned systems operators to fill out if they would like to operate outside of the hobbyist regulations that they have put in place. Obviously not something that your average hobbyist has the time or resources to fill out for every single flight that they wish to carry out. And yes, they do have to fill it out for each and every flight they wish to carry out. Luckily, the FAA is not a lawmaking body. They can only make recommendations to Congress and issue notices to the public. Long story short, if there is not a federal case law on the matter, then there is no law to be breaking. So as of now, we have not had any federal case law on any of the notices that the FAA has put out. That doesn't mean that if you go and, FPV fly somewhere that you shouldn't be, that you're not going to piss the FAA off. So it's one of those things. We currently reside in a very interesting gray area, despite what the FAA will try to tell you that we're not in a gray area. We are. So again, use your best judgment. Don't endanger others. Don't invade others' privacy. Yada yada. Despite that limit on their power, though, the FAA does remain one of the biggest authorities on aviation and are regarded pretty highly by Congress. This public notice that I talked about caused a pretty big uproar in every RC community in the country. FPV flight is achieved with either tiny little screen, an on-screen display that's either on a tripod, kind of like our GoPro here, or you might use a pair of goggles. I don't know if you guys have seen those before. Those are sweet, and I want to get a pair really bad before they get banned. But for a lot of people, FPV flying is easier than sort of line of sight flying. And you know, if you kind of think about it, like if you ever played a first-person shooter or any video game that's a first-person sort of thing, you know, it's pretty simple, you know, forward, forward, backward, backward. It's all very, you know, it's quite well oriented. Whereas, you know, if you're on the ground, you know, flying a plane or, you know, driving a ground vehicle or whatever, it's a little bit harder to sort of keep yourself oriented, you know, especially in the case of airplanes. If you're facing away from you and you know, turn left, all of a sudden you realize, oh crap, it was actually coming towards me and now I'm rolling right. So in a lot of ways, FPV flying is easier for people. In the FAA's defense, though, they're not completely off their rocker. It is feasible for anybody with sufficient knowledge of unmanned systems to put together an aircraft capable of carrying a dangerous payload and flying it more than a mile away into a building, a car, you know, something. Luckily, this is still probably viewed as ineffective from a cost standpoint by ne'er-do-wells, but it is possible. So, you know, again, the FAA is not completely insane. For now, FPV flying is still legal in the US, but the future does remain unknown. So if it were to become illegal after a period of time, I'm pretty sure that we would still see the hardware available under the caution that, you know, it could only be used on land or sea-based systems, or, you know, some caveat on there. But nonetheless, you probably won't see me waiting in the future to get my first headset. So, another recap slide. Woohoo! Unmanned systems are accessible virtually worldwide. Purchase them in a variety of states. The level of accessibility can be seen as both a blessing and a curse. Their components are accessible almost worldwide, but their availability for use does vary from country to country. You do need to think about where your system is being operated during the design phase, and the legal world for us is constantly changing right now. So always keep an eye on that. We actually did get a member who is part of the law school recently. He finds unmanned systems interesting, you know, but doesn't have too much, you know, technical or sciencey background on it. But he thought that it would be really cool to sort of help us out with sort of researching the current laws at a time, you know, when we want to test something, design something, and sort of give us feedback on the legal feasibility of that. So you do have a resource here at the club for that. All right, now we get to the meat and potatoes, characteristics of unmanned systems. I'm probably going to use aerial platforms pretty heavily for most of these examples, as that's what I'm most familiar with, but these basic principles and ideas can be applied to land and sea-based systems. As we move into this section, bear in mind the saying that there is more than one way to skin a cat. What I cover here is not an exhaustive list of these characteristics, nor will they necessarily be the best way to do things, but you know, what's best generally depends on the application that the system is being designed for. So, yeah. Shown here, we've got a short list of applications where unmanned systems already see plenty of action, both in the civilian and military sectors. The most common applications are ones that would otherwise be too hazardous, too time-consuming, resource-intensive, et cetera, for human beings to accomplish. By no means is this an exhaustive list. The applications that are in place for these areas still have plenty of room for improvement, and there's a virtually unlimited number of applications that have yet to be conceptualized for these things. Just to take a second to nerd out here, I do want to highlight that this is a very exciting time to be involved with this sort of thing. We are working on what I consider at least to be the brink of an evolution in the way that we gather data. The work that you do on this team could lead to a job in the world of unmanned systems. At the very worst, you'll have an edge in interviews as unmanned systems gain more widespread use. So that's pretty awesome. I hope you guys think so too. We're also going to talk about the how as far as characteristics are concerned. The vast majority of systems will have the hardware that you'll see on this slide in common. They're the most basic components that are needed to achieve unmanned autonomous operation. Most systems that are capable of carrying out non-trivial tasks will have more hardware than what's listed there, but those pieces are usually the most critical ones to operation. So let's go a bit more in depth on the characteristics of these pieces of hardware. So the motor, the engine controls how the unmanned system moves. It allows you to send signals to the system to control it. They can be gas powered, that's generally when you refer to them as engines, or electric power, which is generally when you would refer to them as motors. Pros and cons to both, most notably being that electric motors can provide more power at a faster rate at the cost of runtime. Conversely, gas engines provide less power but have more potential for extended run times. And there are also differences in how they draw power and everything like that. But and depending on the system, you might also have more than one motor or engine. So, much like in cars, motors do vary widely in size and power output. Smaller and or weaker motors can have a maximum output of 500 kV, and the kV there, so the K is the RPMs, the V is per volt, so 500 RPMs per volt. Whereas larger and more powerful motors can have upwards of 4,000 RPMs per volt. Combination of size and power is going to be the main influence on your price for motors. And then do remember that bigger is not always better. Dumping a huge motor or engine into a small system isn't going to magically make it go faster or run longer. In fact, it is probably going to have the exact opposite effect without adjusting the rest of the hardware on the system. And it might not even work, actually. And to sort of draw that parallel, we'd kind of be like putting an engine from a Dodge Viper into a Dodge Neon and expecting that your Dodge Neon is going to be faster, stronger, better, other quotes from that Daft Punk song. When in reality, you'd probably just have a pretty heavy hunk of metal, and your friends would probably make fun of you because you put a Viper in a Neon. So they would be right to do so, by the way. Don't ever do that. So next we're going to talk about the receiver. If the autopilot is the brain of an unmanned system, then you can kind of think of the receiver as the blood that's helping get everything to where it needs to be. It takes the commands given to the system from your transmitter and relays them through an appropriate electrical signal to the other hardware on board. Receivers need to be bound to a transmitter before they can be used so that the receiver knows what signal it's listening for. Most hobbyist transmitters and receivers work on the 2.4 gigahertz frequency spectrum and make use of channel hopping to ensure that your signals are received with the lowest amount of latency possible. Feature also ensures that your receiver doesn't accidentally listen to another transmitter that might be operating in your area, like if you were at an RC field or something like that. So when the receiver picks up your signal from the transmitter, it translates the input into an electrical current that is passed along to the corresponding piece of hardware. Most basic example, you push that throttle stick up, your receiver is going to send a corresponding amount of current through the servo that is connected to your motor or your engine, and it will then have that motor or engine produce more power. It's not necessary for all of the hardware on board a system to be connected to the receiver, but anything that you want to interface with via your main transmitter does need to be connected to that. Receivers are usually about the same size, but they vary in how many channels they have and exactly how they communicate. That one that I've got pictured up here is a Spectrum AR 6100, a 6-channel receiver that communicates over 2.4 gigahertz using what they call DSM-2 modulation. DSM-2 doesn't hop between channels to ensure communication, but instead listens for 2 free channels and then locks onto those channels to ensure that it receives what your transmitter is sending. DSM-2 has actually been superseded and is slowly being replaced by DSM-X modulation, which does use frequency hopping to keep the communication latency at a minimum. If you want to learn more about those modulations, go to the Spectrum website. So I believe it's spectrumrc.com. Very fantastic company, by the way. That's where I from who I purchase my transmitters and receivers. When you are building an unmanned system, it is very important to pay attention to the instructions included with your receiver. Many receivers have a very specific way that the antennas, you can see those kind of coming off the sides there on the top of the receiver. Very specific ways that those need to be laid in order to ensure acceptable communication latency. There is very little in the world of RC that is more soul crushing than spending hundreds of dollars putting your system together and only to watch it fail to function or worse, crash due to signal loss when you go to test it. There is a saying in IT and related fields, RTFM. I'll let you fill in that acronym, as I'm sure you know what it is. If you don't, Google it. There is an adult word in there, so I apologize in advance if you're sensitive. But anyway, while that concept should be applied to just about everything with a manual, you really need to read the freaking manual when you're assembling an unmanned system, specifically for the receiver in this case. Moving on to the autopilot. Just about every, if not all, pieces of hardware are going to interface with this in some way. The autopilot is what allows the unmanned system to operate intelligently. So for instance, auto leveling when your hands aren't on the sticks. Autopilots can usually be configured within software. To what degree it can be configured depends on the autopilot and the software. But that'll let you fine-tune your flight parameters, set up various modes of operation, like assisted, unassisted, return to home, things of that nature. Basically, the important thing to remember there is that they're what make an unmanned system an autonomous unmanned system. As you can see here in the image, the autopilot provides an array of ports for connecting auxiliary hardware. As I mentioned, additional hardware supported by an autopilot isn't critical for operations, but generally they are critical for autonomous operations. For instance, like GPS sensors, telemetry radios, safety buzzers, things of that nature. Without an autopilot, you cannot do autonomous operations. Pictured up here is the Pixhawk autopilot system that is produced by 3D Robotics. It's one of the more advanced open source autopilots out there. You can definitely find autopilots with more or less features. There are a number of things to consider when selecting an autopilot to build an unmanned system, but the biggest things are size, at least relative to your system that you're building, and power consumption, as well as whether or not it even supports the features that you need to support the application that you're developing this system for. Having more features than necessary isn't always a bad thing. That in this case, it actually leaves room for upward scalability for your applications. But then at the same time, it could have a negative impact on your system runtime due to the autopilot drawing more power than necessary. So really careful planning is going to be your best friend on these, pros and cons to each side of it. It's also important to note that the autopilot needs to be placed as close to the center of gravity, or COG, as possible. It's because certain features on the autopilot, such as that auto leveling and a dead stick that I mentioned before, depend on knowing the orientation of the system. So if we kind of consider two imaginary multi-rotors here, if we've got this one, the autopilot is at the center of gravity, and we'll say that this one is maybe an inch or two forward of the center of gravity. Whenever you move forward and then the system goes to level, this one's going to exert some amount of work to level itself out. This one here is going to have to work harder, however, to level itself out because there is more weight in the front there, so these, I guess that would be the front propellers, would have to work harder to lift the rest of the system back up to a stable position. So not mounting your autopilot at the center of gravity could in fact wind up costing you a pretty significant amount of power draw. Definitely something to keep in mind. Okay, the electronic speed controller, or ESC, is what makes the final conversion from the signal that you send to the receiver to what powers the motor or engine in your system. Actually, just the motor, I take that back. You generally don't see electronic speed controllers in gas-powered engines. Most of the ESCs contain a battery eliminator circuit, or a BEC, which is why the receiver in an unmanned system rarely needs its own power supply. Generally, your ESC is connected to your receiver in one way or another, and that's how your receiver is getting power. and the ESC generates a three-phase power in order to provide a pretty smooth and precise variation of speed for your motor. Again, as I mentioned, for gas-powered engines, don't need an ESC. ESCs do vary in input and output, as well as the maximum amount of power that can be passed through them. Determining which ESC you should use on an unmanned system is usually dependent on the amount of power you have available and what motors you're using. And then last but certainly not least, we have the power. Usually provided by a big boy words there, lithium polymer battery, and can be distributed to the various pieces of the hardware on board in a variety of ways. I would actually go so far as to say that the power system you implement is one of the single most important decisions you can make when designing an unmanned system. The amount of power that you have will decide how powerful your motor can be, assuming it's electric anyway, how big your system needs to be in order to hold the LiPo plus any other required hardware that you've got going on, what ESCs you'll need. Really, it's kind of the determining factor for the other components of your system. LiPo batteries come in a pretty wide range of sizes, weight, power output. Again, all very important considerations depending on the application that you're designing the unmanned system for. You know, a big battery that can run your electronics for an hour is of no use if you can't mount it to the system. So, theoretically, it is possible to power onboard electronics and other things through a gas-powered generator, but you will see that you can pretty much count on one hand with a few broken fingers how many times you're going to see that. All right, I think that's pretty much all I've got as far as how unmanned systems do what they do. Do I have any questions at this point? Are we all clear on that? Sweet action. All right, let's talk a little bit about what they can do then. So for these, we're just going to go through a few applications that have been realized for unmanned systems. Here we see imaging is a huge thing for unmanned systems right now. There are a number of applications where that functionality is desired. Crop analysis, I believe, is what we're looking at here. This image was more than likely taken with an infrared camera, and so we're probably looking at an NDVI image here. I would imagine that the blue and the green there are buildings. Your red there is probably going to be your crops or plants or whatever it is that we're looking at there. Generally speaking, this can be used by farmers to determine, you know, if a crop is sick or not, or if it needs more of this chemical or that chemical and all that. Here we have got an unmanned ground vehicle that is that specializes in bomb disposal. You can kind of see that arm reaching out there, capable of lifting up to 15 pounds. Again, you know, this is a system that, you know, where before, if we, you know, had a bomb threat called in or something like that, you know, you have to send in a huge swarm of dudes, you know, in big bulky armor so that if the thing blows up right next to them, they hopefully no harm comes to them. Whereas with an unmanned system, you know, we can receive that threat and we can go, okay, we need to deal with this. Let's send in this thing that we don't care about blowing up into 1,000 pieces. Obviously, a human life is worth more than we can even put a price on. UAV and UGV systems have started seeing pretty big roles in surveying for construction companies. Again, kind of going back to that whole, the FAA is not a lawmaking body. We cannot use these for commercial purposes, but at the same time, we're seeing a lot of applications come out for commercial purposes, and companies are in fact using these to do things. So again, pretty legal gray area, but yeah, using an unmanned system for surveying allows you to determine the three-dimensional position of points and the distances between them and the angles between them and come up with these crazy 3D topography maps that we see. And then search and rescue efforts as well are a huge area of the field. Here in this picture, we've got a few USVs, unmanned sea vehicles down there on the ground. They're poised and ready to support the UAVs, or I can't really tell honestly if they're working on like a cleanup for an oil spill, or if they're looking for like people or wildlife caught in the oil spill. I don't even know if that's an oil spill, to be completely honest, but Basically, that diagram shows, I can't remember what university was working on this system, but they had an idea for unmanned systems, air, ground, and sea, all working together to work towards some common goal. So, very cool stuff. And then, obviously, they see a lot of action in military applications. The military UAVs that they use, again, pretty obvious, way better than any of the civilian technology that we have at our disposal, which is probably a good thing for, again, some of the reasons that I mentioned before, how accessible these things are. Of specific note is the ability of these things to see. A lot of the, I guess, complaints I hear about people in unmanned systems is, you know, oh, they're invading my privacy, you know, they're, you know, recording me while I cook dinner for my, you know, kids and all that jazz. Generally speaking, in order to actually, like, photograph somebody in their home and stuff, you'd have to be, like, right there at the window. Like, if this monitor is the window, you gotta be right there. And then furthermore, we all know that these things are loud. They are very loud. You're not going to have one all of a sudden come up and, you know, surprise you through your window, unless you've got like soundproof windows or something like that. But yeah, point being, civilian UAVs cannot see nearly as well as some of these military grade ones. But to wrap this one up, know that this world is one that is constantly changing. We make evolutions into the capabilities of unmanned systems on what almost seems like a weekly basis. And we are constantly forced to deal with legislation that is surrounding it. I already said it once this meeting, but it is an amazing time to be doing research and development with unmanned systems, so glad you're here. As we enter the research and development schedule next semester, do bear in mind that in order to develop a successful application for an unmanned system, you need an appropriate platform with which to do it. Off-the-shelf solutions might not always be the answer, but designing one and building it from scratch will work if done properly. Hopefully now, after this meeting, you know the basic pieces of hardware that you will need, and adequate research will help you discover what else you might need to incorporate into your design to carry out the application that you want to provide for. If you get stuck, ask somebody for help. We are all here to work, learn, and have fun together, so don't be a stranger. You know, everybody here is interested in the same nerdy stuff that you are. And lastly, related to the first point, do remember that new applications are being realized every single day. Not a completely wild notion that somebody in here might come up with a new application for an unmanned system that gets the world's attention. And I have another video example for us to watch. There was a dude at a Dutch university that posted this video of a prototype for a multi-rotor that can carry a defibrillator to somebody in need. If you guys are on the Facebook page, you might have already seen this. This was posted to the Facebook page. Our Vice President Chris Dope. Aw, on the real tip? Well, that's disappointing. Basically what it was, and I'll have to...
Might be able to Google it.
Yeah, let's see. Dutch University multi-rotor defib. I'll try and find it later and link it on the OrgSync page if I can find it, but basically what it was is it was a multi-rotor that was designed and painted and decaled with a bunch of EMS sort of labels so that it was very clear that it was being operated by a government official, but it would carry a defibrillator, land, and then basically, you know, let's say it's downtown on a Friday night, you know, there's a bunch of people out at bars and everything, the streets are pretty crowded. Somebody's down and they're having a heart attack, you know, and emergency crews are having trouble coming in and everything. So they would maybe send this multi-rotor with a defibrillator on it and have it land by that person in need, and then whoever's calling 911 is then in charge of, you know, putting the defib on that individual and hopefully getting them awake and back to consciousness before emergency services arrive. Really cool idea, but there are some things that I personally find wrong with it. And I could be completely wrong and they may have already addressed this, I don't know. But one of the first things I thought of was, oh hell no, I ain't doing that. If if something lands by me and they're telling me I need to pump 20,000 volts into this human body, that ain't on my hands. I'm not doing that. I would hate to be the guy that screws up somehow and winds up either electrocuting myself, that human being that's already in trouble, being electrocuted more so than they need to be, or some innocent standby. I don't know, I've never operated a defibrillator, but it just seems to me you shouldn't be putting 20 to 40,000 volts in the hands of people that are untrained to do that. And then furthermore, there, I would think, are a lot of, if we're already talking about a crowded area that emergency services are having trouble accessing, where's this thing going to land exactly? And more so, how is it doing the landing? These are just a few questions that I thought up whenever I saw this video. Again, not trying to downplay the video or the kid's idea, because it's an awesome idea, and we would never have new innovations if people weren't putting ideas out there to be peer-reviewed and talked about. Maybe some of these things are things that he didn't think of. Maybe if I sent him these comments and he was like, I never really thought about that, maybe I'll change this, that, and the other thing, and for all I know, that thing could be coming out here in 2 to 3 years in the Netherlands, and they will have a much better EMS service for people in need. I don't know. But yeah, so that's all I've got on my presentation slides. I'm really happy that we went a whole hour this time, actually, not even with other people's content. Any questions at this point here at the end?
I had a question about the government models. Like, it's understandable why like the Predator drone's not available.
Right.
But as far as the power that it takes to fly that thing for hours, how is that not available? That component, I couldn't see why that wouldn't be.
My theory on whether,
Because I'm sure Boeing doesn't have their blueprints laying around for,
I believe, and so I think that's the key, and this, again, could be completely wrong here, but my theory is that they could be using technology that is not available to us. There's actually an autopilot system called the Piccolo that is, I think it's like $8,500 for this autopilot system. It's a combination autopilot and ground station system. Parts of the Piccolo are actually still classified. Yes, you can purchase it as a civilian, but one of the requirements for purchasing one, foreign nationals are not allowed to work with it, period, because parts of the Piccolo are still classified. And actually here in the basement here, there is, one of the labs down there has like a notice posted on the door that some of the equipment that has been donated to that lab is from the US government. Some of that equipment is still classified. So again, non-citizens cannot use that equipment. Back to your original question though, I figure it's either one of two things. Either they are using components that are not available to us in order to achieve those long flight times, or they are using components that are available to us, but they have not released their configurations, and nobody yet has come up with a configuration to give similar flight times, or run times, I should say.
It's also cost effectiveness. The government kind of has like an unlimited budget.
That's true as well. They've definitely got a lot more money at their disposal, and what is cost effective for the government isn't the case for civilians much.
Well, that's what I'm saying. I thought a lot of those systems were like half a ton, like huge, heavy systems.
It depends. I guess it depends on. So we might be thinking of different systems. I was thinking more of the one that was pictured, one of the, I guess, backpack drones that like army men would carry around and toss up into the air. I guess you're maybe thinking about things more like Global Hawk and the Reaper and things of that nature. Okay. I think in those instances, we're definitely talking about hardware that is not available to the public. If I had to take a stab in the dark, obviously.
I could ask. I actually, for First Robotics in Columbia, we have a mentor from Boeing that
Really?
does the electronics on like drones.
Yeah, if you wouldn't mind
Yeah,
asking your
I'll
contact
check.
with them and seeing if he could.
Yeah,
I'd just be curious to know.
I know they use some of the stuff's still the same because he was showing me like, one way you can get more efficient and faster controls using an FPGA instead of a typical microprocessor. So he was showing me like that's what he does, this program. But yeah, I think he works on a couple different like drones. One of them he was talking to me about disables landmines. So like flies over an area and like tries to like
I assume that's through like electromagnetic signals or
Yeah,
something like
I
that?
think, or it puts like a countercharge just to get them to go off,
Huh.
so then the area is safe.
Wow,
That's
dude. That is super
But yeah,
cool.
so I don't know how much of that, of course, you can talk about because I've never
Sure,
asked,
yeah.
but-
Trade secrets and all
You may be
that.
like, but I know that some of the technology, at least that they work with, is very, very similar to civilian use. Just they have more money to develop it and buy the top of the line rather than the cheap stuff.
Sure, sure.
Yeah.
Part of it also is the drones that you guys were talking about. Those are essentially flying fuel tanks.
That's what I was
Yeah.
thinking. They were like,
The wings are fuel tanks. The fuselage is a fuel tank. Like they've got.
Yeah, I know in the
just
case of the
whole thing's a
Global
fuel
Hawk,
tank.
like, if it's not being used to house electronics, it's probably housing fuel. So,
that would make sense why that wouldn't be available though, because if that crashed over anything,
Yeah.
I mean,
that would be awful.
you would just build your own fuel tanks. And
Yeah,
Yeah, I
right.
mean, you can build one with the same specifications. It's just maybe that's more of an ethical question at that point.
now you mentioned flight times, and that's actually something that's been, I guess that's one of my interests right now, because as someone who has a few civilian unmanned systems, like, it's really fun to go fly my quads and go fly my planes out at the airfield, but it really sucks that I have to land them every 5-10 minutes and then switch out my batteries, put my batteries on chargers, all that jazz.
I feel like that's the biggest hurdle, I guess, with finding other uses for them. Because I mean, if you could get even an hour out of them, I could picture so many more
Yes.
uses.
This was actually posted just yesterday on rcgroups.com is a very excellent website for just general RC news in case you were curious. One of my favorite sites to go to anyway. This was just posted there. They haven't released these just yet, but it does boast that it was designed with flight time in mind. And if I remember correctly, yep, they have left enough room in there for you to mount a 6-cell high-capacity battery. And so I don't know how much this frame is going to cost, but I'm going to see if we can't acquire one of these. I think it would be really neat. Again, flight time is a huge thing that needs to be addressed, if you ask me. And part of me wonders if maybe the systems that we see that keep coming out by these designers and everything, I'm wondering if flight time is maybe limited intentionally. Again, kind of for some of the same reasons about the cons of them being so available for anyone, that once you have long endurance capability, that kind of opens up a new world to things both good and bad. Again, complete theory there. I don't know if that's why the design choice is to keep the flight times at about, excuse me, 10 or 15 minutes. I don't know if that's the case, but it seems to me that would be a likely reason, or at least one likely reason why they would keep the flight time so low.